Okay, so first and foremost, if you haven't made your help sheet, then I think you realise you should have done that by now, because that will help you to do some of that stuff. And then you go, oh, I better put stuff on here. Now, question like this, we did in class, we did an assignment. I think if you go back and have a look at the various tests, has anyone looked at a previous test? Not yet? Okay. You'll find there's questions like this, and it might not be tan theta equals 5/2, it could be sine theta or cos theta. My tip for this, who can remind us? What do we do? It's a shape. It's the triangle. I would go, it's the triangle. So you do the triangle. And I've drawn mine not very well, not in proportion at all, as you will now see. And it doesn't matter that it's not in proportion, right? Because tan theta, what is tan theta? It is opposite over adjacent. So here's my opposite. So that's the 5. And that's why I was laughing before, because clearly that is not a very good triangle. It's not to scale. I don't care. I'm not going to erase. I'm just going to move on. And now, using our best mate, Pythag, what will my hypotenuse be? The hypotenuse will be 5 squared plus 2 squared, 25, 29, root 29 thereof. Are we happy with that? Okay. We're then looking at, would you like to say anything, Miss Metheringham?
Sorry,
you're on record now. Hi. That's our guest speaker. We then draw our attention to our domain here, which is telling us what? Quadrants, yeah? So little bit of a whoosh. Here's pi, here's 3 pi on 2. So we're talking here. That's confirming that in that quadrant tan is positive. But what will sine be? Sine will be negative because it's downstairs, right? So sine negative, and we know that sine is opposite over hypotenuse. So therefore, sine theta will be negative. What's my opposite? 5. My hypotenuse is root 29. Our cosine, right? That doesn't really change colour, does it? We'll go black. Our cosine is going there, so that we know is also negative, and you know, we also know that negative divided by negative is a positive, and we know that cos theta is adjacent over hypotenuse, so therefore cos theta will be, right, adjacent is here, it'll be negative 2 over root 29. Right, I would say this would probably be maybe out of 4 to 5 marks. 2 marks for possibly your triangle. What's the other way that you could have done this? Pardon? It's the formula. When you say formula, some people are going, what formula? Sine squared. Oh, actually, no, we couldn't do this. Sine squared plus cos squared equals 1. I'm thinking you could use that if it wasn't tan theta, right? If they gave you sine theta or cos theta, then you could use that formula. But for this one, the triangle is the only way. So I love the triangle. If it was me writing this test, I'd go tan, because you can't use sine squared plus cos squared. I love the triangle. Okay, if this was a test question, obviously the layout would be better, but I would make sure that you go through and do everything that you can do first. So would we agree that amplitude, most people know, the amplitude, that's the A value that stretches the graph or shrinks the graph. So in part A, what would my amplitude be? A half. Now, in hindsight, what I would like to do is I'd like to go back and make this minus a half. What would my amplitude be now? It's not minus a half. Your amplitude would still be 1/2. Okay? Oh, I did it for part B. Oh, I'm amusing myself. Very good. So again, in part B, what's my amplitude? Excellent, right? Your amplitude, remember we're talking about, I'm running out of room here, but we're talking about y equals A sine, so A is your amplitude. So for this one, it is just 4. Not -4, but just 4. Okay, what's my amplitude for C? Lucy said there is none. I was hoping to catch you out, right? Let's be honest. I was trying to trick you. So you're going, oh, A is a half, A is 4. What's A here? 5. But remember, for tan, your amplitude is undefined, because it just goes up and up and up and up and up near the asymptotes. Did anybody put 5? Come on, be honest. Yeah, good. Caught a few. So this is good. Make sure that we don't do this in the... Okay, what would we like to do next? You want to do the period, the max, or the min? Period, okay? So if we're doing the period, what do we straight away come to mind? What should we be thinking? Right, so for part A and part B, we should definitely be thinking period is 2 pi over B. Now, what is my B value in A? It's 2, right? So the B. So period will just be 2 pi on 2. So therefore the period is pi. Happy with that? For B, it's going to be 2 pi divided by what? 2/5, okay? The coefficient of x here is 2/5. Again, as I'm doing this, part of me wants to go back and change that. Instead of just 2x5, part of me wants to make it 2 pi x on 5, because then the pi's will cancel out. So you can pop that into your calculator if you want to. Mine is a little bit away. So 2 pi times 5 over 2. Those 2's cancel out, so I've got 5 pi. But again, you could just type that into your collator and it would tell you. Okay, what about for C? What's my period there? Right, that's the thing I'm checking. The period for tan is not 2 pi, it's pi. So once again, this will now be pi over 2, because here's your B value. And we'll just pop that pi on 2. I only wanted this to take a moment, right? So we didn't do heaps and heaps and heaps, but obviously you've seen questions where we have this. Actually, we'll do it in the last question, where you're given the period and you need to find B. So working backwards, but we'll come to that shortly. Would anyone like to tell us about the max and the min? Taj, are you too cold? I can turn it off. Who's going to tell us about how we find the max and the min? I'll pause.
Max is D plus A and minimum is D minus A.
Love it. So your A value is making it go to the max and to the min, right? So your maximum, if there was no D, would be a half. Do we agree? Because that's what it's stretching it out to be. This A here, it's taking it up to a half. Well, I'm saying stretches. It's shrinking it down to a half. But then what's going on with this D? It's dropping every point down by 4, correct? So my max would actually be a half, take 4, whatever that would be. And then my minimum would be minus a half, take 4. Yeah? So I guess as Luce said there, and I like what you said, wish I'd said it, I guess the maximum is your amplitude. I don't want to say, I say plus D value, but will you make sure you're including the whole negative? And then your minimum will be your minus of whatever your A value is, subtract your D value. But I really like what you said, Luce. Okay, so knowing that, what would B be the max of? What's my A for B? That sounded weird, doesn't it? What's my A for B? What's my A value for part B? Yep, it's the 4. And again, we don't care about it being minus because even though the minus tells me that it's going to go down first, it's still somewhere going to go up, isn't it, to maximum of 4. So it's going to have the 4, and then we're going to add on that 3. And then it will be minus 4, add on that D value of 3. And you can work that out. And of course, the max for the tan one, well, it's unlimited, really, isn't it? Unlimited. Anyone seen that symbol before? Some of you might have jewelry, infinity. And your minimum minus infinity. Uh-oh, I've lost my... There, it's back. I was doing just then, I had a quick look at my equation. So before I got my ruler out and was drawing my axes, I wanted to look, well, what was my maximum and my minimum going to be? So just like we did in the previous question, this here is my amplitude. So I know it's swinging between 8 and minus 8. And then it's every point is being lifted up by 3. Because if you just got your ruler and you went like this, you're going to run out of room because then you might be going, oh, I have to go up like this. So have a stop and a think before you actually go to your ruler. And do you need to use a ruler in your test for your axes? If you would like full marks, yes. So bring a ruler, bring a straight edge of some sort. Am I recording now? Yes, I am. Okay, so, and then the other thing that I looked at was this pi on 4. So I know already I'm going to have to shift the graph over by pi on 4. So instead of going over by 3's here, can you see how I've gone over by 1? I've counted 1, 2, 3, 4. Because now that bit there is pi on 4. So every 2 squares I know is a shift of pi on 4. Happy? Okay, so here we go. I'm probably going to start with, I'm probably going to start by drawing 8 minus 8 sine 2x. Okay, because what do I know about that? I know that it's going to swing between 8 and minus 8. Instead of going up to 8 first, it's going to go down to 8. And I'm going to have a complete lap within pi units. Why within pi?
Because B is 2.
Because B is 2, okay? So I'll just stop because the video will get too long. If you need to do it in a few more steps, by all means, do it. You might want to just do minus 8 sine and then do the 2x. That's up to you. So we've done this. Okay, now I'm actually now going to shift everything across by the minus pi on 4. So which way am I going to go?
Hi, miss.
Hi. Right, I'm going to go right by pi on 4. So what did we say pi on 4 was? That gap there. So every point goes across by pi on 4. I put probably a cross or something to indicate, and then I just connect all of my dots. Right? Nice and smooth. And I think we've got the gist now that all I have to do to actually get to my final product, which we'll do in black, I guess, is what do I have to do? Just move every one of these, what are they called? Pink dots up by 3. Okay? So I'll leave you to do that. But what we now want to do is check on our graphics calculator. And some of you, when you put this into your calculator, got a straight line. So I'll just give you a couple of minutes, finish off what you need to, and then grab your calculator, please. So I was a bit sneaky when I typed this deliberately, because it can be typed like this and you just have to be nice, but I know you'll be given it nicely. So this is what we did in the books the other day. You must put a bracket around that. So 2, and then it's bracket x take. So the reason that some of you were getting straight lines is your calculator was just working out sine of 2. And so that might be a very small or whatever number, right? Sine 2 will be point something, and then it's just timesing it by your varying x's. And that's why you get a straight line, because it'll be linear. I've checked already that I am in calculator mode, radians mode. Okay, so those blue brackets are essential. I press enter. If I just press draw, God knows what my last scale was. So I'm going to go shift view window, 0 to 2 pi. Now, can you see my min and max, my y values there? Because these were the like 4,500 and 10,000. Now, we already know what our max and min is, right? Just want to show you one little thing. So I could go down here and change this to 11 and minus 8. That would be my go-to. But I just want to show you this. Get nothing. Shift. Can you see I've gone to F3, zoom. If I go zoom and I go auto, it'll do it for me. That works best if you put the X values in. So just showing you little bits and pieces on your calculator. If you want to use that later on, let me know. How can you check that your scale is pretty good? Well, again, use your Shift G-Solve max. Does your max compute with the one that you've got, and so on and so forth? Okay. Okay. Who wants to tell me how we're going to do these ones? We want to look at these graphs and we're trying to find the A, the B, the C, the D for each one of them, okay? So, what's my A for the first one? Yep, it's pretty simple. We can see that it's 6 and yep, Finn's going, it's minus 6 because the sign is going downstairs first. Okay, it doesn't look like it's been lifted up or down, so I'm going to be pretty confident to say that D is 0. What's the next one that you'd probably look at? Jades, what would you go for? We've got A, we've got D. We've got 2 left. Pick one. The period, right? So we're going B equals 2 pi over B. And we look, how am I meant to find my period? So how long is it going to take for it to complete one cycle? I'm a bit excited because I'm going to use my highlighter now. Right, so it starts here, going up, and then boom, it stops right there. That's one cycle, and then it starts repeating itself. Would you agree? So what's its period there? Right, it's 4 pi is the period. Again, we've got Smarty Pantsers who's already going ahead and can see that, therefore, when the B is downstairs, we're going to do the switch. So, yep, it was a half. Has the graph moved left or right? I don't think it's moved left or right because you got the 2 pi there, yeah? It's going straight through. So C would be 0. So therefore, Y, my thing is going to be minus 6 sine x on 2. Or minus 6 sine a half x. So just a reminder, if you can't sort of look and see what the A and what the D are, then you've got these little formulas that again are in OneNote that you could have a look at. So we can see, I hope you can see pretty clearly that the principal axis, the whole thing has been lifted up. All right, and we can see that the max was 14, the minimum was minus 6, so we're adding 14 plus minus 6 over 2, and we get 4. So my principal axis is 4. What is my A? That would be 10. You can fill the bits in, would you agree? Because you've got your max and your min on your right. Do we need anything else? What should we be looking at? C, senor. I'm saying it started on its increase right at the principal axis, so I don't think it's moved left or right. So I'm pretty confident to see C is 0. Oops, meant to go white there. What about A? What about B? How are we going to get that? So it's completing one lap. I'll get my highlighter out again. Let's go green. Highlight. Oh, I want to go green. Zoop. Whoosh, whoosh, whoosh. So it's completing one lap in pi. So up to you how you want to do it. Period equals 2 pi on b. So it's pi equals 2 pi on b. Therefore, again, I know some of you are just looking at it and go, I can see that it's 2. I get it. I can see it too, but I'm just showing the steps. So y would be 10 sine 2x plus 4. Okay, so